Okay, welcome students. This is our video introducing ideas on quadratic functions. The first thing that we need to do is recognize there are two different forms. There's general form and vertex form. General form looks like this. Okay, it looks like a quadratic on the other side. You don't have a lot of information in the form, but it is in the form of a quadratic. Vertex form looks like this. I'll call it g of x, okay? Now, this should look familiar to you. This is the form of a quadratic that has certain key information in it. You may remember the h moves it to the right and left. The k moves it up and down. The a makes it wider or more narrow. And the negative out in the front makes it normal or flipped over the x-axis. So vertex form and general form. You need to know that. Okay, now I call this all about quadratic functions. What we're talking about is if we have a certain parent or family of functions, it is helpful if we know all about one type, and we study that first. So this is a quadratic function. It's in vertex form, and I want to know all of this information about it. Well, first of all, I graph this. As you know, it's to the right 1 and down 2. So this purple point right here is called the vertex. So the vertex, V, is equal to 2, negative 1. Now also, you're familiar with the idea of a parabola. This curve is that name, okay, it's called a parabola. And there's a line that goes through the middle. It's a line of symmetry. In this case, this green line is called the axis of symmetry. Axis of symmetry. Now another question we could ask is, what is the equation of the axis of symmetry? And if you notice in this particular spot that the axis here is going through, it's a vertical line, so it's an x equal line. It's actually x equals h, but in this case it's x is equal to 1. Now why did I have that? I had that backwards, didn't I? Let me fix that. Sorry. 1, negative 2. So the equation of the line of symmetry is x is equal to 1. Alright. Now, what are some things that we need to know about this? First of all, what's the domain? Well, I could use any x value in there, so it's all real. You could say this, okay? Or remember our notation, okay? Now, what's the range? Well, it doesn't go down forever, okay? It stops right here. As a matter of fact, the y value it stops at is called the minimum, and that value is negative 2. So its y is greater than or equal to negative 2. Can I write that in interval notation? Yes, it can be negative 2, and it goes to infinity. So that's important to keep in mind. Now, another thing would be the y-intercept. Give me the location where it crosses the y line at. Well, if we notice in the picture, the x is going to be 0 there. So to find the y-intercept, just plug in 0 for your function. Okay? So if I plugged in 0, that would be a negative 1, but negative 1 squared is 1, so 2/3 minus 2 is negative 1 1/3. Negative 1 1/3. I could write it like that if I wanted to. Now, what is the x-intercept? To find the x-intercept, that would be these points right here. And notice in that case the y is 1. So what you do for this is you set the y equal to 0 and then solve. These points right here are called the zeros because the x value causes the y value to be 0. That's important to keep in mind. Now, is it shaped up or is it shaped down? If we look over here in the front, we notice that's a plus 2/3, so it's going to be opened up, or a regular bowl, not a flip bowl. And now we want to talk about increasing and decreasing. Now, the function, the value of the function, or the y values for all of these points on the function are going down, okay, and they stop going down right there. So that would be decreasing. It decreases from negative infinity, and where does it stop decreasing? At 1. Okay. Now I'm not going to sweat that. You could just put parentheses there. Increasing from 1 to positive infinity. So 1 to positive infinity. Increasing and decreasing. And then the last thing is, notice a parabola. It'll either have a minimum point or a maximum point, a valley or a mountain, and this one has a minimum. And the minimum or maximum is always going to be at that vertex, which is h comma k. So keep that in mind. In this case, it's 1 comma negative 2. So 1 comma negative 2. Now, the minimum of the function is actually the negative 2, but the domain value that it happens is at 1. So please keep that in mind. All right, this is a short segment. Identify the vertex and axis of symmetry. Well, in this case, h comma k. So for the top one, v would be 5 comma 13. And because it's negative, it's going to be this way. That would be a maximum, right? And the axis of symmetry would be x is equal to 5. All right, let's look at the bottom one. On the bottom one, it's opened up, but it's a little wider, okay? And the vertex is located at negative 7 comma negative 12, okay? And we know that because x minus a negative 7, that is your x value. And of course, the axis of symmetry is the equation x equals negative 7. So that's helpful information. Okay, the question is we want to be able to put these two equations in vertex form. All right, so without making this video a lot longer, let me just do this top one right here. So in other words, if this was a function, let me get a, I'm just going to use my red right here, f of x, okay? Now, so this is y is equal to, now notice what I do. It's like the completing the square, but I'm just leaving a space. I take half that middle coefficient, which is 2, and I square it. So again, 2 squared is 4. Now what I'm going to do is I'm going to add the 4 right here and subtract the 4. I really didn't change anything on the right side of that equation. So now I have y is equal to x plus 2 squared, and 9 minus 4 is 5. So now it's easy to graph this. It's opened up, okay? The vertex right here is at negative 2, 5, and that would be a minimum point right there. So that's how you use complete the square. Okay, now this is a little bit more involved. Find the vertex and graph. So I'm going to follow the same procedure. I'm just going to say y is equal to, this case I'm going to pull the negative 1 out and make that x squared plus 2x. I'll close a parenthesis there and say plus 3. I really didn't change anything on the right side. Now let's go through that procedure. What is half of 2? Half of 2 is 1. Now square that, you get 1. So I'm going to add 1. But the trick here is not to just copy in -1. That would be a mistake. What you'll need to do is you need to realize that's a -1 times a 1. So you really added a -1 on the right side. So to undo that, you got to add 1. Now, if you need to multiply that out for you to see that, you can, but that's the gist of that right there. Now we could rewrite it. -1x plus 1 squared plus 4. So what's the vertex? The vertex is at -1, 4, and notice it's going to be this way, and also notice that would be a maximum. Now the maximum would be the value 4. That will be this value, and the domain where that occurs at is x is equal to -1. Hope that helps. Now class, you may remember from high school there was this business about -b over 2a, and so what I did here is I just started with a general form, and I solved the general form using the complete the square procedure, and I got this binomial squared. This is vertex form right here, and notice over here the x value would be -b over 2a. So the vertex of a general form, there's the x, and then there's the y. Normally it's a lot easier to just find the x and then plug that value in to find the y. Let me explain that. If I go back to that last problem that we did, I recognize if I look up here at the top, a is equal to -1 and b is equal to -2. So if I use the formula h is equal to -b over 2a, that would cause me to have, well, b's -2, so -b would be 2 over 2a, and then that would be 2 times a -1, which is -2. So h is -1. Now, in order to find the k for the vertex, okay, k, I could plug the -1 into the function. So that would be -1 plus 2 plus 3. And that's 5 minus 1, which is 4. So that's another way to locate the vertex using this -b over 2a. Okay, here's a question. Find the maximum or minimum, and here's my quadratic function. Well, we know that this -4 in the front causes the graph to have this general shape. And that means that this vertex would be a maximum. Now, we want to find the maximum or the minimum. So in this case, we have a maximum, and we understand that. I have to find the x and the y there, which is really h comma k, correct? So let's find h. I could do my -b over 2a. That would be -24 over twice a, which is -8. And then, of course, that is 3. So now I know the x value there. But when I said find the maximum, that's like saying how high is the mountain. You have to find the y. So let's do that. Okay, I worked that out, and of course I plugged it in, and then I multiplied it out here. 72 minus 36 is 36. 36 minus 35 is 1. So that tells us that the maximum value of the function is 1 and occurs at x equals 3. In this question, we are given a vertex, and then we're given a point, and we need to be able to write the quadratic function. Okay, in this question, in order to figure this out, we have to use vertex form, and so I plugged in the vertex. Now what I did is I plugged in the value of x and y for that point. It's a point on the curve, and I solved it for the a. A is -13 over 36, and I plugged that back in here. This is the function. This represents that quadratic function given those parameters, and I could graph that, and that point would show up on the graph. Hope that helps you out.